All right, so today we're going to keep talking about Python classes. We talked yesterday about inheritance. So, a class is a way of reducing repetition in your code. So I want to make a bunch of objects or whatever, and they all have kind of the same basic properties. So instead of, again, individually creating all of them anew, you abstract those common properties or methods into a class, and then you can create instances based on that template. You can also kind of add some extensions to that basic feature where you can have a class that inherits from a class. So if you have a basic class like we were making, you have like an animal class, and then you have a subclass, which is, a whale, and then you can have a subclass, which is a tiger or whatever. You can also have multiple, you can have lots of inheritance, lots of levels of inheritance. So I can have an animal class, then I can have a mammal class, then I can have a canine class, then I can create a poodle instance. And so I can use, the poodle can use everything that belongs to all of its subclasses. So canine, mammal, and animal. So that's one way of kind of reusing stuff, right? So that's the whole goal, right? We want to be able to reuse stuff as much as possible. Another way of extending the functionality of a class is to use something called composition. So composition is it's a way of creating a class or creating lots of classes and then kind of putting them together into one class. So if I have a lot of different features, a lot of different components, and I want to use all of them, maybe inheritance just doesn't quite work. It's not quite as clean. There isn't enough common between different instances. So you might want to use something like composition. So we'll look at, you can take a look at this if you want. I'm going to do a different example here. So what I like to do is make you can do anything, but I'll just say robot. If anyone else has a better idea, feel free to suggest it. So let's just say we're going to make a robot. So class. She's okay. Class robot, and then def init stuff, and then what we're going to do is so a robot. Let's say a robot is going to have certain features. So a robot will have like a head and a body and then legs, let's say. So we can do, just like we would do in a normal class, we can make sure that any instance of this robot class will have a head and body and legs. So do something like head, body, legs. And then we'll do self.head equals head. Body equals body, self.legs equals legs. All right, and then if this is just a normal class, right, we could create an instance. So I don't know, equals and we'll just say 2. We run this. You can see that we get a body. So this works, right? So we've created a class. We give it 3 instance attributes. And then when we create an instance, we pass those in. And then this R instance will have all the things, right? So we should be familiar with this by now. Let's say we wanted, well, so if we want to make different kinds of robots, one thing we could do is we could use robot maybe as a base class, or maybe like machine could be a subclass, depending on how we wanted to organize things, right? There's a few different ways we could do that. But let's say each robot is just kind of different. Each robot is maybe like potentially very different from any other robot, or maybe we have a lot of specialized components that we want to use that might not be as simple as just, like a variable or an object or something like that. So one thing we can do, instead of passing these, let's say, fairly simple things in as attributes, is we can create a whole bunch of classes. So we can have like a head class and a body class and a leg class. So let's look at, let's make those. So class. And then let's make a body. Yeah, we could, we could add all kinds of properties and attributes. We could extend these. This is kind of, as simple as possible here. And then let's make a leg class. Yeah, something like that. Let's do number. All right, so now we have these three classes for a head, body, and leg, and each of these classes could have all kinds. They could have their own set of attributes and methods, and even their own inheritance structure, and so on, right? So all of these classes could be as complicated as you like. Now, if we want to make a robot, right, we want to compose a robot, right? So it's going to be composed of all these other components, all these other classes. What we can do is create instances of all the parts that we want to use. So we can do and then body. And then leg. Four legs. And then if we want to create a robot based on these parts, we can just pass those in. So
I think line 12 needs to be self.number.
oh, thank you. Okay, so we have a robot object. So what if we want to see the leg? So let me add a method to all of these. uh, and I'll do this for leg as well. Okay, so let's say I have my I have a robot now. So what if I want to see, you know, information about this robot's body? How could I do that? Any guesses?
I think just use dot notation to access those properties. So like maybe my robot dot body,
Okay.
and then call the method dot get size.
Anyone else have any other thoughts? Anyone agree or disagree?
You'll probably want to put that in a print statement.
Yep. Okay.
I don't know if this is the way it works or not, but I remember you mentioned that Python essentially does like a series of lookups. So I wonder if you did my robot dot get number, if it would essentially see it's not in my robot, and then it would check the additional classes to see if it's in there.
Okay. So that's a good thought. So I will say that's a good thought, but it won't work. So it'll only it'll look for it if it's yeah. Let's just try doing it.
It'll look up, not over and down and wherever else.
Yeah. So is this robot inheriting from body? So if it were inheriting from body, then you would be able to do that. But robot, this class by itself doesn't know anything. It's not connected to any of these other classes. So the only way, you know, this, in a sense, the robot class doesn't know anything else about these classes. It just has these attributes, and these attributes happen to be classes themselves. So this should work. 5 meters. So just to recap, what we've done is we created this robot class, and then we assigned as instance attributes a whole bunch of other instances of classes, right? So head is an instance, body is an instance, legs is an instance, and my robot is also an instance of a class. And because these are instances, we can access anything that an instance can access, including attributes and methods. So my robot can access the get size method of its body. It can access the get number attribute of its legs.
And then the way it's connected, the way my robot is connected to the classes of head and body and leg is through the variables that you assigned in 31, 32, 33. And if you wanted to call them like head 1 and body 1 and leg 1, those names don't have to match anything. Those are independent.
You mean here? These
no, in 31, 32, and 33. then you would just have, like, if you wanted to make those my robot's head or my robot's body, my robot's leg, yeah, then you would just change it, yep, on 35. Because they're not connected, those variables are not connected at all to
No,
the classes above them.
this is just whatever, I mean, this is totally up to us.
But robot is connected to the other three based upon that def statement, def init self.
Yeah,
and head, body, and legs in it.
it depends on how you want to think about connected to, but there is no direct connection between robots and these other classes.
Okay.
It's only connected through the variables that we assigned outside of any class.
Yeah. So you pass in an instance of another class as an attribute, and then this instance can access. You're basically, accessing a class from another class. So it's a bit weird maybe, but it's kind of like in the same way that a function taking in another function as a parameter is kind of weird. But you can do this with classes as well. A class can take another class as a parameter. You can think of it that way.
So if it's not connected through what's in that init statement, then you can put anything in that init statement that's not related to those classes above?
Yeah, I mean, technically we could. We could also add some kind of check here if we wanted to. Something like if head is, so this is a, I think you can do this. Head Let me try doing something like this. So I mean, if you wanted to make sure that only instances of these classes could get passed in, then you could do some kind of like, it's basically like a type check. You're making sure that whatever this parameter is an instance of the head class. So you could do something like that if you wanted to kind of restrict that. But without doing any kind of check like that, then yeah, this head could be anything, and this body could be anything. But
It could be arm, knee, and feet.
how's that?
It could be arm, knee, and feet instead of head, body, and legs.
Yeah, right. Yes. Yeah, you could. But that would be, I mean, that would be confusing. So you would want to, if you're designing this as something that other, the other people or other components we're going to use, you don't want to make sure, you don't want to make your intent clear, and you probably would want to do something like this in order to make sure that people are using your class as you intend them to do, and other people should also kind of act in good faith and maybe not deliberately try to misuse your robot class. But for, if we're thinking about like security and things like that, then you can't obviously rely on other people's goodwill. In fact, you can do the opposite.
Is there, I'm not sure if there would be a use case for this, but would you be able to pass a class as a parameter of the init method onto another class? Like if you just wanted only metal spike heads as a head for your robot, could you put that into the line 25 head spot?
Yeah, so I mean, you could do something like, I don't know, if, as a default parameter, if you can create an instance of a class. Let's give it a try. Let's do oops. Okay, yeah, so I'll have to change the order. So let's make, instead of that, let me just do this at the end. So we'll do the example with legs, so I don't have to move everything around. All right, I'm doing numbers. Let's do 1. All right, so if I don't pass in a leg, sorry, let me delete this confusing stuff. All right, let's see. So let's
You've
do,
got an extra comma on 36, looks like.
okay. Actually, it doesn't, sometimes trailing commas don't, in JSON, trailing commas definitely matter. There are cases where actually they're required, but yeah, that was a mistake. So we'll do robots dot get. I guess you can. I'm not sure that I would want to do this. This seems a little, but yeah, you could. I guess you can create an instance of a class. I think probably a better thing to do would be maybe like do none and then
You can do the thing. I think the thing yeah. So you can pass in the class reference and then just use legs. Whatever class you pass in as legs, you can talk to it like it's a class, so you can make an instance out of that thing. I don't know if that made any sense at all.
yeah, I mean just something like this.
Or no, like you don't have to set the default parameter. You can say whatever class is passed to this thing, I want to just create an instance off whatever was passed. So like line 37, you can say the third argument is a class instead of an instance of a class. So you could say leg for the third argument on line 37.
Yeah, I thought she was asking about default, like not just passing a whole class in and then creating an instance, but actually making sure that it was this particular instance. Was that the question? Or?
Yeah, I was curious if you could pass it in as a parameter and make the instance like in the init, what do you call it? Like when it's initialized,
Yeah.
you create the
So it looks like you can do this, although this doesn't quite feel right to me. I would probably want to think of another way of doing that, but I don't, that's just a bad feeling I'll have.
I would be interested, well, because every time you create an instance of robot, you're creating an instance of leg, but it's not going to be the same instance of leg because every time an instance is created, it's a different instance.
Yeah, it should be
a different address or whatever. Yeah.
Yes, we can do.
Interesting.
Legs. Name this more consistently.
And yeah, if you really want to test that, you want to make a second robot too.
Yeah.
Because there's actually a problem with passing a default parameter as a list because it's immutable. I'm wondering if it has the same effect actually. I've never tried to do a default instance parameter like that.
Assume my robot too.
If they have the same ID, then don't do it. They have the same ID. Yeah, don't do it. Don't do that.
I'm surprised they have the same ID because I was expecting that it would create a new instance every time it creates a new instance of robot, but it looks like it's It's just doing it the one time and passing that into every robot.
Yeah, so if you think about how Python comes through and reads this thing,
Yeah.
when you run when Chad runs Python comp.py, Python reads this from top to bottom. It actually compiles, it reads the file from top to bottom. It compiles the class and all of the method signatures right then and there. So if your method signature has an instance in it, it's saving that as a reference for every time you call it now. So that's why it has your method or function parameters have to be immutable objects. They can't be mutable. They can't be like a list or a, you don't want to set like an instance of a dictionary, instance of a list, because those are mutable items. When it compiles the references for these, you don't need to know all this. Sorry, let me prefix it with this. You don't have to have this mastered yet. This is just what's happening. It's basically storing that instance of a leg reference for every single time you create an instance of robot. So you want to do what Chad probably had initially, which was either pass none or just don't pass a default parameter as something that is considered mutable, like an instance is technically mutable. But yeah, I thought that's what was going to happen, because it happens with lists too. It's a really weird side effect of mutable types.
Well, let me try doing this then. Yeah, so
There is
I
one
think
more.
you could do something like this. So legs. No, legs. And if I pass in, I guess we could play off the top of my head. I don't know the good way to like. I don't know of a good way to do this. I'm sure we could play around and figure it out.
Yeah, this is what you're doing right now is what I was originally going to try to tell you
Yeah.
to do. Yeah,
Yeah.
this right here was, I think this is what Jess was originally trying to ask if this was possible to do. If I was understanding right.
The issue with this is we have to pass it an instance, or we have to pass it the class. Okay. Okay.
And you got to print it.
That's what I was trying to do the time. So we get different. Well, so these are different. Yeah, actually, this is that. So these are creating different things. So this one would work. The problem is, I guess depends on what your design is, but the problem is we have to pass an instance, or we have to pass the class in, which may not be.
You might not be able to count on it passing out.
Yeah, it would just depend on how this was designed. Sorry,
But-
that was
Yeah. Sorry for the
a slight tangent, but no, it's I think it's cool. But yeah, does anyone else have any questions? So the basic idea here of so there are two basic paradigms for kind of reusing classes, or expanding what classes can do. One is inheritance, And inheritance is a relationship, right? So if we have an employee and then we have an accountant, we can say that, you know, employee is the base class and accountant is a subclass, right? So an accountant is an employee, right? We wouldn't say that, you know, an accountant has an employee, anything like that. So an accountant is an employee. So it can inherit from employee and use all of the employee functionality. If your design requires a different kind of relationship, something like a has a relationship. So in this case, we say that our robot has a head and a robot has a body and a robot has a leg or has legs. So in that kind of relationship, you use composition rather than inheritance. So if the relationship between a class, you know, between one class and another class is a relationship, then you use inheritance. If it's a has a relationship, then you use composition. Any questions? So you can think of this as an introduction. So this is just an introduction to composition. So by this point in the class, what you really need to be able to do is create a class and create instances of classes. Knowing how inheritance works is good. And composition at this point is just kind of, I'm just exposing you to this right now. Okay. All right. So I'm gonna stop sharing real quick. Okay, are there any questions about composition or inheritance? All right, so let me talk about the assignments. Feel free to look at the README again if you want another pass at this. So we have 2 challenges for today. Mode is just like, you know, I think a fairly simple algorithm. So if you just want some more algorithm practice, then there's mode. And Boggle is going to be similar, you know, it's going to be an object-oriented challenge. So you should be able to do this in just one class. But if you're feeling especially eager and you want to maybe expand this a little bit, you could try using inheritance or composition, depending on what might work with this use case. But don't worry about that unless you're especially eager to, you know, expand what you're doing. But so here you'll just create a class and you'll kind of have to represent, similar to what we did with the tic-tac-toe challenge, right? You have to kind of represent the board internally. You have to be able to display the board, and then you'll have to write a method that will randomly basically create a new board. All right.